high grade 9s, as I go through this PowerPoint with you, you should have open these covalent bond notes, and you'll be filling them in as we go through. So up until this point, we have been talking about ionic bonds. Ionic bonds are formed when you have a cation, or a metal that has lost electrons, and an anion, which is a nonmetal, which has gained electrons, and they are bonded together by having the same number of positives as you do negatives, and that electrostatic force holds them together in an ionic bond. Well, what we're going to be talking about today is covalent bonds. These are the friendly bonds, the sharing bonds, the bonds that are going to share electrons and become friends. So these are our sharing electrons. They only happen with nonmetals. There are no metals, none, no metals in covalent bonding. So you need to know where the nonmetals are, and hopefully you know that they are on the top side of the staircase over here. And then hydrogen is our only special one over there that acts as both a metal and a nonmetal property. We are still trying to fill our valence electrons, or our valence electrons are still what is going to be doing our chemistry, and we're still trying to fill that valence shell because that gives us the most stability. So, just review. What is the Lewis dot diagram? We have done these before. Lewis dot diagrams show us only our valence electrons, the outermost shell. And these we can tell by looking at our periodic table, because group 1 has 1 valence electron, group 2 has 2 valence electrons. Group 13 has 3 valence electrons. Remember, we have to skip over top of our transition metals. Then group 14 has 4, group 15 has 5, group 16 has 6, which is where oxygen lies. Group 17 has 7, and group 18 is a trick. It's not 8, it's full. Okay. So, if you have a Lewis dot diagram for these ones, fluorine is in group 17, so we'll have 7 valence electrons. Nitrogen is in group 15, so we'll have 5 valence electrons. Carbon is in group 14, so it will have 4 valence electrons. A covalent bond, co means joined or partnered. So covalent means that the valent part is that outer shell, so it's going to share or partner to have the right number of valence electrons. So they're going to share what goes around the outside. They're not going to transfer. They're going to share it. A covalent bond is also called a molecular bond. It's a chemical bond that involves sharing of electron pairs between atoms of nonmetallic elements. So our nonmetals sharing is a covalent bond. Compounds formed by covalent bonds are known as molecules. You have an oxygen molecule that has 2. A nitrogen molecule has 2. A water molecule has hydrogen and oxygen joined together by a covalent bond. Carbon dioxide is a molecule because it is held together by molecular bonds, or by covalent bonds. Molecular bonds, covalent bonds are like a good handshake after a deal is made. For many molecules, if the sharing of electrons allowed each atom to obtain its full outer shell, so its full valent shell. Just a reminder, because we did this before with our octet rule, this is the chemical rule of thumb that atoms of main group elements tend to combine in such ways that the atom has 8 valence electrons. It wants to look like a noble gas, right? So it wants to have that full valence electron. Now remember, group 18 is known as full, not 8, because that one at the top is helium. Helium only has 2. So hydrogen only needs 2 to be full because it's in that top row. That top row only needs 2 because it wants to look like helium. So what you have is you have bonding pairs. So when you share your electrons, you have a bonding pair. That's your handshake that allows them to become an octet. So here, carbon has 1, 2, 3, 4 in its outer shell, and oxygen has 6 in its outer shell, and therefore to share, carbon shares 4 with oxygen, and oxygen shares 2 of carbons. So here you can see that you've got here, by sharing 1, 2, 3, 4, 5, 6, 7, 8, carbon has 8 here, whereas this oxygen has 1, 2, 3, 4, 5, 6 of its own and 2 of carbons, making this have 8, and this over here, oxygen, also has 8. So in the carbon dioxide molecule, the carbon is extended by 4 hands, and each oxygen is extended by 2 hands. So there are 4 handshakes or bonding pairs in the molecule, which can be represented by straight lines in a Lewis structure. So we're going to change from the Lewis dot to a Lewis structure just by making our handshakes now, showing our 2 sharing electrons here into these lines. The lines means that there's 2 electrons. Pairs of electrons are not engaged in the handshake and are called lone pairs. You don't need to know what lone pairs are. We don't deal with those in grade 9. All you need to know is that these sharing pairs here are represented by lines. So if you want to know how many sharing bonds you can have, hydrogen can only form 1 because it has 1 electron to share. Oxygen has 6, so it wants to share with 2. Nitrogen is in group 15, so it needs 3 more, so it will share 3. Carbon is in group 14, it will share 4. So that tells you how many bonds, honk, 1, 2, 3, 4, tells you how many bonds you can get with other nonmetals on the periodic table. So carbon can have its 4 bonds in any order it wants. Oops, sorry. Hydrogen only has 1. Oxygen can have a double bond. Nitrogen can have a triple bond. These double and triple bonds we don't deal with. You don't need to know how they work in grade 9. You just need to know that they can be bonded in any way. That's all you need to know. So you will have to be able to write a couple of them, be able to represent what the molecule looks like. But I will show you the molecule first. So one of your assignments this week will be finding a way to show me how a molecular molecule looks. And I'll give you examples, and then you will find things around your house to make those examples at home. So if we did 2 chlorine atoms, you see that we have 1 by itself here and 1 by itself over here. So those 2 are the ones that we need to put together to bond, to share in our bond. So if we rearrange our dots so that our singles are together, we can now show them with a circle around all 8 of the dots, with these 2 being shared by both of them. Will you have to draw all of these dots and circles? Absolutely not. But that explains it so that you understand why it's happening. So you would have the dots shared around like this with the ones that you're sharing in the middle. Now, because we're sharing 2, that becomes 1 line between it, because the bond of 2 becomes 1 line between. So you would get this as your final drawing. Now, if you were to draw this for me, you would not have to draw the circles around the outside. You would just write CL line CL. But will you have to write that? It'll probably not come up. You just need to know that this is a chlorine covalent bond. If you wrote this as a molecule, you would just write Cl2. You do not have to show me the bond. Just Cl and 2 of them together. This is called a diatomic molecule. There are 7 diatomic molecules. They're called the gens PS. Well, the gens are the diatomic, so they go along as 2. I will do a different video about gens PS just so that's more clear. All right, so if we did the same thing, could you have hydrogen and nitrogen create a covalent bond? Absolutely. But the problem is hydrogen only has one bond to share and nitrogen wants to have three. So how do we solve this problem? We're going to add more hydrogens. So you're going to have three hydrogens all sharing their one electron to make nitrogen have 8 and each hydrogen have 2. So I will just read what it says on the clipboard. In this case, you start by writing just one of each of the atoms, but you must add 2 more hydrogens to create a complete handshakes for the full outer shell of all atoms involved. This element that we're making right now is called ammonia, which is represented here. And that is how you draw it. Again, you don't have to draw the lone pairs, and you're just going to have to recreate 2 molecules for me this week. This is called ammonia. It's also called nitrogen trioxide. So we'll go over how to name them after this. So what I want you to do now is I want you to go back to this. If you haven't been doing it at the same time, go back here and make sure you have all of these filled out because we just did them. And then try this. I will go over this part with you in another video after this.